December 1942, Richmond, California. The Kaiser shipyards roared through the night, cranes swinging steel plates over sparks that lit the fog like fourflies. Here, an idea was taking shape that would change shipbuilding forever. Henry J. Kaiser's engineers had abandoned the old riveted hulls of the past and turned to welding, a radical method dismissed by traditional shipwrights as unreliable. But welders proved them wrong. By assembling prefabricated sections side by side, working around the clock in rotating shifts, they created ships faster than anyone thought possible. In just 4 days, 15 hours, and 29 minutes, the SS Robert E. Peary was completed, a Liberty ship built from keel to launch in less time than it took to paint a battleship. The world watched in disbelief as America transformed shipyards into factories and workers into legends. The ridiculous welding revolution had just turned the tide of World War II. October 27th, 1942. Richmond, California. The fog rolled in from the bay, carrying the smell of salt and oil, settling over a landscape that had once been little more than mudflats and grass. Now, it was a forest of steel. Cranes the size of church steeples loomed above the water, lifting prefabricated hull sections into place as welding torches hissed in the darkness. From a distance, the shipyard looked less like a factory and more like a living organism, breathing, grinding, and pulsing with light 24 hours a day. This was Henry J. Kaiser's empire of speed, the place where the mathematics of shipbuilding had been rewritten, and where the modular system that would make Liberty and Victory ships possible had just begun to change the course of the war. Before the war, building a cargo ship was an affair of patience and tradition. Each vessel took close to a year to complete. The process began with the keel, laid down like a spine, then built upward, piece by piece, by craftsmen working in sequence. Each part depended on the one before it. Riveters hammered steel plates by hand, shipwrights measured with chalk lines, and the sound of hammers echoed through wooden scaffolding. It was the same method that had been used for decades: slow, steady, reliable, and completely inadequate for the demands of global war. By 1941, Allied ships were being sunk faster than they could be replaced. German U-boats prowled the Atlantic, sending convoys to the ocean floor by the dozen. Britain's survival depended on supplies from across the sea: food, fuel, ammunition, tanks, and men. The United States had to find a way to replace ships faster than the enemy could destroy them. The answer came not from the old shipyards of the East Coast, but from a man who had never built a ship before the war: Henry J. Kaiser. Kaiser was not a naval architect. He was a builder of dams, highways, and impossible projects. The Hoover Dam, the Grand Coulee. His name was already a synonym for speed and efficiency. He believed that the same principles that moved concrete and steel across mountains could be applied to shipbuilding. To him, a shipyard was simply another assembly line, a factory that needed only rhythm and coordination to produce miracles. In 1941, when the Maritime Commission called for new yards on the Pacific coast, Kaiser offered a plan that shocked traditional builders. He proposed not 1 yard, but 4, each capable of producing ships faster than any in the world. The secret, he said, would be modular construction. The idea was deceptively simple. Instead of building an entire ship in one place, Kaiser's engineers divided it into large sections, modules, that could be built simultaneously at different stations. Each section contained everything it needed before being moved: pipes, wiring, bulkheads, and fittings. When complete, these enormous steel segments would be hoisted into place and welded together like pieces of a giant puzzle. In theory, 10 or 20 ships could be under construction at once, each advancing through the stages like a war on a production line. It was an untested system, dismissed by many as impossible. Ships, they argued, were not automobiles. They required craftsmanship, not mass production. But Kaiser ignored them. He hired industrial engineers instead of shipwrights. He recruited anyone who could hold a torch or drive a rivet gun: men, women, and migrants from every corner of the country. Within months, the Richmond shipyards rose from the ground in perfect symmetry. 4 vast yards, each with multiple ways, assembly areas, and prefabrication shops. Conveyor belts carried steel plates through cutting and shaping lines. Overhead cranes moved finished sections to storage yards awaiting assembly. Work never stopped. 3 shifts a day, 7 days a week. By early 1942, the first sections of the Liberty ships began to take form. Unlike traditional hulls, which were built from the bottom up, these ships began everywhere at once. A bow section could be welded in one area, while the stern and midships were prepared hundreds of feet away. The speed was astonishing. Every hour shaved from construction meant another ship in the water. Each Liberty ship required about 250,000 separate parts, produced by more than 1,000 subcontractors across 30 states. Trains brought pre-cut steel from Pittsburgh, boilers from Ohio, engines from Wisconsin, and fittings from small machine shops scattered across the Midwest. It was an orchestra of logistics so vast that even the Navy struggled to comprehend it. The first results were awkward. Sections sometimes failed to align. Weld seams cracked under stress. Plates warped when cooled too quickly. But each mistake was treated as a lesson. Engineers adjusted the jigs, changed the welding angles, and refined the sequencing of assembly. Within months, construction time dropped from 200 days to less than 50. The modular system was proving itself not in theory, but in steel. The heart of Kaiser's success was organization. Every task in the yard had a number. Every worker a clear assignment. Men and women were trained in schools set up directly within the shipyards, welding academies that could turn a factory hand into a certified welder in 2 weeks. Foremen tracked progress with colored flags raised above each section: green for ready, yellow for inspection, red for rework. The shipyard became a choreography of motion: trucks delivering sections, cranes swinging overhead, torches cutting and sealing steel plates. Each operation fed into the next with mathematical precision. Government inspectors were stunned. The Navy had expected chaos, but instead found rhythm. At its peak, the Richmond complex employed more than 90,000 workers. Some were teenagers. Others were mothers whose husbands fought overseas. They called it Kaiser's miracle. But inside the gates it was simply normal life. Workers joked that they could set their watches by the sound of the lunch whistles, by the flash of torches lighting up the night sky. Entire families worked side by side, one cutting steel, another wiring electrical systems, another running the cranes. The modular system changed everything about how a shipyard operated. In traditional yards, a single ship occupied one slipway for months, preventing new construction until it launched. In Kaiser's system, sections were prepared off-site, freeing the ways for rapid assembly. It was like preparing all the ingredients of a meal before lighting the stove. When everything was ready, the assembly moved at impossible speed. Entire hulls came together in days. On the drawing boards, engineers began to design with modularity in mind, standardizing parts so that the same bulkhead or deck section could be used across multiple ships. This standardization cut waste, reduced training time, and allowed parts from one yard to fit perfectly in another. By mid-1942, the scale of production began to astonish Washington. The first Liberty ships launched from the West Coast at record speed. Each new vessel carried vital supplies to Britain and the Soviet Union: steel, ammunition, food, and fuel that would keep the Allied war machine alive. But to Kaiser, speed alone was not enough. He wanted to break the psychological barrier of shipbuilding, to prove that construction measured in months could be measured instead in days. To achieve this, he pushed the modular system to its limit. He ordered larger prefabrication shops, more cranes, and around-the-clock crews. He demanded that sections be welded and stored before the keel was even laid. When the Maritime Commission hesitated, fearing safety issues, Kaiser replied with characteristic calm, "The only way to build faster is to start before you start." It was not bravado. It was planning. By pre-assembling modules weeks ahead, he ensured that once a ship's keel touched the blocks, the rest could rise like a structure already half complete. At Richmond, each shipyard became a city unto itself. Cafeterias fed thousands per shift. Hospitals treated welding burns and fatigue, and childcare centers allowed mothers to work full hours. It was a social experiment as much as an industrial one. The workforce reflected the country's diversity. Okies from the Dust Bowl, sharecroppers from the South, Filipino and Chinese immigrants, and African Americans drawn by the promise of steady wages. For many, it was their first industrial job. The modular system's simplicity allowed them to learn quickly. Each person trained for one specific task, repeating it until perfection. The results defied belief. By late 1942, Liberty ships were launching so fast that the Navy struggled to assign names. Some were finished in under 10 days, others in just over a week. Then, on November 12, 1942, the ship Robert E. Peary began construction at Richmond Yard, No. 2. Workers had prepared every section in advance. As cranes lowered each module into place, welders sealed the joints with showers of sparks visible across the bay. 4 days, 15 hours, and 29 minutes later, the ship slid into the water, fully built, painted, and outfitted. Newspapers called it a miracle. Kaiser simply called it proof. The world took notice. British observers toured the yards, astonished at what they saw. In Belfast and Glasgow, where traditional shipwrights still hammered rivets by hand, the idea of welding and modular construction seemed heresy. Yet here, in California, ordinary men and women had achieved what centuries of craftsmanship never had: mass production of ships on an industrial scale. The ridiculous system had worked. Inside the yard, efficiency studies continued daily. Engineers timed every motion, from crane swings to weld seams. They discovered that the average worker's torch could seal more than 50 feet of weld per hour. Assembly diagrams were redesigned to minimize wasted movement. Sections were pre-painted before joining, reducing corrosion. Even lunch breaks were scheduled to maintain the rhythm of work across shifts. It was not exploitation, it was orchestration. Each improvement shaved minutes, then hours from the clock. The modular shipyard system soon spread beyond Richmond. New yards in Portland, Vancouver, and San Francisco adopted the same blueprint: prefabrication shops, numbered stations, continuous assembly. In Portland's Swan Island yard, construction times dropped below 7 days per ship. The miracle had become routine. At the height of production, a new Liberty ship slid down the ways every 8 hours somewhere in America. The scale of the operation was staggering. Each Liberty ship measured more than 400 feet long, weighed 7,000 tons, and could carry over 9,000 tons of cargo. To build one required 3 million man-hours of labor, yet the modular system compressed those hours through overlap and parallel work. Welders in one yard could work on hull sections, while electricians prepared wiring looms in another. When combined, the ship emerged as if assembled overnight. Not everything was perfect. Early weld failures caused hull cracks, especially in cold waters. Investigations revealed that rapid cooling of the welded seams made the steel brittle. The solution was another innovation: preheating sections before welding and developing new low-temperature steel alloys. Each setback refined the process further. Problems that would have crippled traditional yards were solved in weeks because modularity allowed experimentation without halting production. If one section design failed, it could be replaced without stopping the entire ship. Kaiser's shipyards became symbols of national will. Newsreels showed endless rows of women in welding helmets, sparks lighting their faces as the narrator's voice declared, "Ships for victory." Visitors compared the yards to vast symphonies of motion. Every crane, every torch, every heartbeat seemed tuned to the same rhythm. In 4 years, the United States would produce 2,710 Liberty ships, an industrial achievement unmatched in history. The modular system did more than build ships. It changed the psychology of war. It demonstrated that America could outproduce any enemy, no matter how efficient their armies. German intelligence reports struggled to explain how a single yard could deliver ships faster than an entire nation. Japanese strategists dismissed the reports as exaggerations until captured intelligence photographs proved them true. The speed of production meant that every sunken vessel could be replaced in weeks, sometimes days. The oceans themselves seemed to tilt in the Allies' favor. For the workers, the transformation was personal. Each launch was a celebration. Bands played, families cheered, champagne bottles shattered against fresh hulls. The name of each ship carried meaning. John W. Brown, Jeremiah O'Brien, Robert E. Peary. Many were named after ordinary Americans, teachers, ministers, journalists, and engineers. It gave the war a human face, a sense that every person hammering or welding contributed to victory. Behind it all stood the quiet precision of modular organization. The shipyards functioned like a living organism, steel arriving at one end, ships departing from the other. Even waste materials were recycled. Scrap from cut plates was melted and reused. Welding rods were counted and distributed with mathematical precision. The system was so efficient that when the war ended, military planners used it as the blueprint for post-war industrial expansion. Henry Kaiser's innovation did more than win a war. It redefined how nations built. The modular method would later influence aircraft assembly, housing construction, and even space exploration. But in 1942, its purpose was simple: survival. Each ship that left the Richmond yards carried with it the proof that organization and imagination could outpace tyranny. By 1943, Kaiser's yards were launching a ship every day. Across the country, new workers arrived weekly. Farmers from the Midwest, miners from the Appalachians, clerks from the cities, all drawn by the promise of steady pay and patriotic purpose. The modular system absorbed them effortlessly. Each man or woman was trained for one station, one motion, one role in the great machine of production. It was the democratization of industry, proof that complex miracles could be achieved not by specialists, but by ordinary citizens united under clear direction. When the Robert E. Peary touched the water, the world finally understood what the modular shipyard system meant. It was not just faster construction, it was industrial warfare waged with precision instead of blood. Every welded seam was an act of defiance against the idea that dictatorships were inherently more efficient. Every finished hull was a declaration that freedom could build faster than fear. By the end of the war, the numbers told the story. From 1941 to 1945, America's shipyards produced more tonnage than all Axis powers combined. Kaiser's modular system alone accounted for a significant share of that output. In total, his yards launched more than 1,500 vessels, each one a monument to coordination, innovation, and audacity. Standing on the pier in late 1945, as the cranes went silent for the first time in years, Henry Kaiser said only one sentence to the reporters who gathered around him. "We proved what ordinary people can do when given a plan." Behind him stretched rows of empty slips, once filled with the clang of progress. The war was ending, but the legacy of his system was just beginning. The modular shipyard system had turned mudflats into factories, workers into builders, and a nation into the greatest industrial power the world had ever seen. It was born from necessity, perfected through experimentation, and proven by results that defied every precedent. In the end, it was not just a method of construction, it was a philosophy. Build fast, build together, build for victory. February 5th, 1943, Richmond, California. The night air trembled with the sound of industry, the steady percussion of hammers that once echoed through every shipyard in the world had gone silent here. In their place came a new rhythm, sharper, faster, brighter. The hiss and flare of electric arcs filled the darkness as welders crouched over seams of glowing steel, their masks flickering with light. Sparks rained against the concrete floor like molten snow. For centuries, ships had been held together by rivets, thousands upon thousands of hand-driven bolts sealing steel plates like stitches in a wound. But in this place, the future of shipbuilding was being written not in hammer blows, but in electric flame. The age of the welder had arrived. Before the war, shipbuilding was a craft more than an industry. A single hull could require up to 3 million rivets, each one heated red-hot, inserted into a hole, and hammered tight by teams of men working in pairs, one inside, one outside. They were called riveting gangs, and their rhythm defined shipyards from Belfast to Boston. The sound was deafening. Hundreds of hammers striking in unison, thousands of plates ringing like bells. The work was dangerous and exhausting. Riveters stood on narrow scaffolds above open hulls, their hands blistered, their lungs filled with wartime and dust. The work demanded precision, but it also demanded time. Every hole had to be drilled, every rivet inserted, every seam checked. It was the same process used since the days of steamships in the 19th century, and it was far too slow for the world's most urgent war. When Henry Kaiser began his shipyard revolution in 1941, he knew that the rivet would be his greatest obstacle. The nation faced a shortage of skilled riveters. Training one took months, and the pace of production required tens of thousands. Riveting was also heavy labor, work few women could perform, which became a growing concern as men left for military service. Kaiser's engineers needed something faster, lighter, and less dependent on brute strength. The solution was already known, but largely untrusted: welding. Electric welding had existed since the late 19th century, but it had rarely been used in large-scale ship construction. Traditional shipbuilders considered it risky. A bad weld could crack. A weak weld could fail catastrophically under strain. Rivets, for all their weight and inefficiency, could at least be seen, counted, and tested by sight. Welds required a kind of invisible faith, trusting molten metal to fuse perfectly without gaps or bubbles. The US Navy had experimented with welding in small patrol boats and tankers during the 1930s, but few believed it could work on ocean-going cargo ships weighing thousands of tons. Kaiser believed otherwise. His engineers argued that welding, done properly, could make ships not only faster to build, but stronger and lighter as well. A welded seam was continuous, a single bond of metal that eliminated the overlapping plates and thousands of holes required by rivets. Every pound saved in weight could be translated into cargo. Every hour saved in assembly could be turned into another ship at sea. The numbers were compelling. Riveting accounted for nearly 1/3 of total construction time in a traditional yard. Eliminating it could cut production schedules by months. The skeptics were loud. "Welds will crack," they warned. "The hulls will tear open in rough seas." One naval inspector famously declared that welded ships would come apart like a cheap suit. But Kaiser pressed on. He argued that the only way to prove the method was to build with it. His shipyards were equipped with the latest automatic and semi-automatic welding machines, imported from industrial plants that had used them to construct pipelines and bridges. The goal was simple: make welding a science, not an art. Training centers sprang up across the West Coast. Men and women lined up to learn the trade. Inside tin-roofed sheds, instructors demonstrated how to hold the torch, how to control the bead, how to read the color of molten steel. Within 2 weeks, a beginner could join a team. By the end of 1942, Kaiser's yards employed more than 25,000 welders, many of them women, nicknamed burners for the glow of their torches. The war had brought the nation's first industrial gender shift, and welding made it possible. The torch, unlike the hammer, relied on skill, not strength. Each Liberty ship contained roughly 600 miles of welds. In a riveted ship, overlapping plates created seams vulnerable to leaks and corrosion. A welded hull, by contrast, formed a watertight skin. The difference was immediate. Ships built at Richmond and Portland were lighter by several hundred tons and required less fuel to cross the Atlantic. They could carry more cargo, and because their seams were continuous, they leaked far less. The first test came with the Patrick Henry, launched in September 1941, the prototype of the Liberty ship class. Though partially riveted, it incorporated welded sections to evaluate performance. The results astonished even its critics. The ship's hull was smoother, its handling improved, and its production time nearly halved. Encouraged, Kaiser's engineers proposed fully welded construction for the next series. By 1942, every Liberty ship built on the West Coast was almost entirely welded. The transformation was not without cost. Early on, some hulls developed cracks, particularly in cold northern waters. These fractures spread suddenly along welded seams, prompting headlines that questioned the safety of the new technique. Investigations revealed the cause was not the welding itself, but the type of steel being used, brittle under freezing temperatures. Metallurgists developed new alloys with higher ductility, and welders were trained to preheat joints before fusing. The problem, once identified, was solved in weeks. The experience turned every shipyard into a laboratory. Each floor became a lesson. Each lesson, a refinement. In the welding shops, innovation never stopped. Automatic welding machines, known as submerged arc welders, began replacing manual torches for long seams. These devices fed continuous wire under a blanket of flux powder, creating flawless joints faster than any human hand. Operators could weld several feet per minute, their arcs hidden beneath clouds of white smoke. It was mesmerizing to watch. Sparks fountained into the air as steel fused silently beneath. For the first time in history, entire hulls were assembled without a single rivet. The new process changed the rhythm of the shipyard. Riveters had once worked in teams of 4 or 5. Welders could work alone. The noise fell from a roar to a hum. Supervisors could actually hear each other speak. The shipyards became almost eerily quiet, lit only by the flicker of arcs dancing across steel plates. The change in sound was more than symbolic. It marked the death of the old era. Productivity soared. In early 1942, a Liberty ship still required about 230 days to build. By the end of 1943, welding had cut that number to less than 50. Some were completed in under 10. The modular system amplified this speed, allowing different sections to be welded simultaneously before being joined. Welders worked in rotating shifts, 24 hours a day. Sparks fell from scaffolds at midnight, as if the stars themselves had descended into the yards. The efficiency was measurable not only in speed, but in cost. A riveted ship required 2,500,000 pounds of steel. A welded Liberty ship used roughly 200,000 pounds less, saving material that could be turned into tanks or aircraft. Welding also reduced the need for skilled hammermen, who had once dominated the trade. Instead, the new workforce was a mosaic of Americans: farmers, clerks, teachers, and housewives, all learning to weld for victory. They came from every corner of the nation, drawn by posters promising steady pay and patriotic duty. Photographs from Richmond show lines of women in overalls, faces hidden behind heavy masks, sparks cascading around them like fireworks. They worked in pairs and trios, crawling through half-finished hulls, sealing seams overhead while molten droplets rained down. Their gloves smoked, their boots burned, but their production broke every record. Each torch stroke was a small act of defiance against the belief that only trained craftsmen could build ships. The Navy's skepticism faded as the results spoke for themselves. The first all-welded ships survived violent storms across the Atlantic, their hulls flexing rather than cracking. When torpedoes struck, welded seams often held long enough for crews to escape, a difference between life and death. Reports from captains praised the durability of the new ships, calling them tougher than they looked. The skeptics had been silenced by evidence written in steel. By mid-1943, welding had become the standard across all major shipyards. Kaiser's methods spread eastward to Bethlehem, Newport News, and Mobile. Even conservative builders in New York adopted the practice. The shift was so rapid that the War Production Board issued new guidelines. All future merchant and naval auxiliary ships were to be welded unless technically impossible. America had officially abandoned the rivet. The psychological effect on the workforce was profound. Welders, once seen as peripheral laborers, became the heroes of industrial warfare. Newspapers published photos of women welders under headlines like "The Girls Who Win the War." Celebrities visited the shipyards to pose beside them. Rosie the Riveter, the cultural icon of wartime labor, was herself a symbol of this transition. A riveter in name, but a welder in reality. Her torch replaced the hammer. Welding also changed how engineers designed ships. Freed from the need to overlap plates for riveting, they could simplify shapes, streamline hulls, and reduce drag. The Liberty and later Victory ships had smoother lines, greater strength, and less maintenance. Internal structures became more efficient, with fewer joints and reinforcements. The result was a generation of vessels that could be produced quickly and operated safely for decades. Many Liberty ships, built in haste for a single war, would still sail in peacetime fleets well into the 1970s. In Kaiser's yards, the spirit of experimentation never ended. Welders competed to set records for the longest continuous seam. Teams developed new techniques for welding vertically and upside down, creating joints that defied gravity. Engineers calculated tolerances by hand, adjusting amperage and electrode thickness on the fly. Every improvement was shared instantly across the yards. What began as a risky experiment became a science executed with assembly line precision. The numbers were staggering. By the end of 1944, American shipyards were producing a Liberty ship every 8 hours, somewhere in the country. Each one contained more than 600,000 individual welds. The welders at Richmond alone consumed over 3 million pounds of welding rod per month. Electricity usage soared to levels previously unimaginable, enough to power an entire city. Yet the system ran with flawless coordination. The transition from riveting to welding also redefined industrial training. The Navy established the welding school at Mare Island, where instructors from Kaiser's yards taught advanced techniques to military engineers. Universities added metallurgy programs focused on arc welding. Welding journals published new standards, and the American Welding Society codified safety regulations that would endure for decades. The war had turned a fringe trade into one of the most respected professions in modern engineering. Welders themselves carried a quiet pride. Many had never seen the ocean before coming to Richmond. Now they built the ships that crossed it. They understood the stakes. Every seam they sealed was a lifeline for soldiers waiting on distant shores. When a Liberty ship slid down the ways, crews cheered not just for the vessel, but for the invisible bonds holding it together. Those bonds were theirs. Not all welds were perfect, but the modular system allowed inspection at every stage. Radiography, the use of X-rays to detect internal flaws, was introduced to check weld integrity. Defective sections were cut out and re-welded before assembly. The process was methodical, scientific, and relentless. By 1945, the failure rate had dropped below 1%. When the war ended, the legacy of welded ships was undeniable. The speed, efficiency, and reliability they brought had redefined naval logistics. Riveting would never again dominate the industry. Post-war shipbuilding adopted the same techniques for tankers, freighters, and warships alike. The lessons learned under Kaiser's arc torches became the foundation of modern marine engineering. Historians later called it one of the most important industrial revolutions of the 20th century. A transformation as significant as the invention of the steam engine or the assembly line. It was not simply a change in tools, but in thinking. Welding proved that innovation could come from necessity, that progress often begins with defiance. For those who lived it, the memory remained vivid. Welders remembered the heat on their faces, the hum of transformers, the metallic smell of ozone. They remembered nights when the entire bay seemed to glow with sparks reflected on the water. They knew they had built more than ships. They had built momentum, a belief that no task was too large if broken into parts, if every hand held steady. By 1945, America's shipyards had produced more than 2,700 Liberty ships and hundreds of larger Victory ships. Nearly all were welded. The rivet, once the symbol of industrial might, had vanished into history. Its replacement, the electric arc, had reshaped not only steel, but civilization. The switch from hand riveting to all welded hulls made ships lighter, faster, and far less prone to leaks. But it also did something deeper. It turned the act of building into a collective triumph of precision over tradition, of innovation over fear. It was, as one foreman in Richmond said, the spark that lit the arsenal of democracy. And that spark, glowing blue in the hands of a welder under a dark California sky, would carry a nation to victory. September 27th, 1941, Baltimore, Maryland. A crisp wind swept across the harbor as the first Liberty ship, the SS Patrick Henry, slid down the greased ways into the Patapsco River. Bands played, cameras flashed, and shipyard workers cheered as the vessel struck the water with a thunderous splash. The name was symbolic. Patrick Henry, the voice of American defiance, whose cry for liberty had ignited a revolution more than a century earlier. Now, in a different kind of war, his name was reborn on steel. That moment marked the beginning of the most ambitious shipbuilding program in human history, an industrial campaign that would redefine not only how ships were built, but how wars were won. By the fall of 1941, the situation at sea was desperate. German U-boats prowled the Atlantic in wolf packs, sinking merchant convoys faster than they could be replaced. Britain, cut off from supplies, teetered on the edge of starvation. Food, oil, ammunition, and raw materials all came from across the ocean, and every ship that went down meant fewer supplies reaching Allied shores. The equation was grim. If the Allies could not build faster than the Axis could destroy, the war would be lost not on battlefields, but on shipping routes. America's answer would come not from admirals or generals, but from industrial engineers armed with blueprints and blowtorches. The U.S. Maritime Commission, anticipating the growing crisis, had already been working on a design for an emergency cargo ship, something cheap, simple, and fast to build. In 1940, they borrowed heavily from a British design known as the Ocean class, a slow but sturdy freighter that could be mass-produced. American engineers simplified it even further, stripping away decorative features, reducing the number of curves, and replacing rivets with welded seams. The result was an ugly, boxy ship with a single stack, a single screw, and a top speed of just 11 knots. To naval traditionalists, it was a monstrosity. To engineers, it was a masterpiece of practicality. It could carry 9,000 tons of cargo and be built in a fraction of the time of a conventional vessel. When President Franklin D. Roosevelt inspected the plans, he understood immediately what was at stake. He called it a dreadful-looking object, but added, "She'll deliver the goods." That phrase became the ship's unofficial motto. What followed was an industrial mobilization on a scale the world had never seen, a national effort that would turn America's shipyards into the beating heart of the arsenal of democracy. The Maritime Commission awarded contracts to every major yard capable of construction, and dozens of new ones sprang up almost overnight. On the East Coast, Bethlehem Fairfield in Baltimore and Todd Bath in Portland expanded to full capacity. On the Gulf, yards in New Orleans and Mobile joined the effort. But the true epicenter of the Liberty Ship Revolution was the West Coast, the 4 Richmond yards under Henry J. Kaiser's command. These facilities were designed specifically for speed. Every process was broken into stages, every component standardized, every movement studied for efficiency. The Liberty ship would not be built by shipwrights working sequentially. It would be assembled like an automobile. Each yard was divided into prefabrication zones, where steel plates arrived pre-cut and ready for welding. Sections of the hull were built in parallel: bow, stern, midship, deck houses, each completed independently before being hoisted into place. At peak production, hundreds of these sections moved through the yard simultaneously, a choreography of cranes and sparks. The process turned shipbuilding from an art into an assembly line. What once took a year could now be done in weeks. The statistics were staggering. In 1941, before the program's full expansion, American shipyards produced just 38 Liberty ships. By 1943, they were launching nearly 3 every day. The total would eventually reach 2,710, more than any single class of ship in history. Each vessel cost roughly $2 million to build, compared to $5 million for a traditional freighter. They carried everything from tanks and trucks to grain, coal, and ammunition. Some even transported troops and aircraft. They were the workhorses of the war, unglamorous, unyielding, indispensable. The modular system and all welded hulls were the keys to this speed. Traditional ships required riveting teams that worked sequentially, but welding allowed simultaneous progress across multiple sections. Prefabrication yards turned out complete modules with piping, electrical wiring, and insulation already installed. When a ship's keel was laid, the rest followed like clockwork. Sections were lowered into place, aligned with precision jigs and sealed in hours. It was as if an ocean liner were being built from kit parts. Each ship contained roughly 3,400 tons of steel, 50,000 feet of pipe, and 125 miles of welding seams. The work demanded coordination on a national scale. Railroads delivered prefabricated components from across the country: engines from Cleveland, boilers from Philadelphia, propellers from New Jersey. Entire trainloads of steel arrived daily at the yards. Nothing was wasted, and nothing stopped. Every 24 hours, the yards consumed enough metal to build a small city. The workforce behind this miracle was as remarkable as the ships themselves. Nearly 600,000 men and women worked in the shipbuilding industry by 1943, many of whom had never touched a piece of steel before the war. They came from farms, factories, and offices, drawn by patriotic duty and the promise of steady pay. Kaiser's yards became famous for their inclusivity. Women welders, known as burner girls, worked shoulder to shoulder with men. African American, Mexican American, and Asian American workers all found employment in a country still deeply segregated elsewhere. The Liberty Ship program was not only a technical revolution, it was a social one. Kaiser's innovations extended beyond production lines. He established health clinics, housing developments, and childcare centers to support his workforce. His company even introduced the concept of prepaid medical insurance, the forerunner of modern health plans. Every detail of life inside the shipyards was engineered for efficiency. Cafeterias operated on 3 shifts, serving meals around the clock. Transportation systems moved workers to and from their jobs with military precision. The result was a workforce that could sustain continuous operation without burnout. By 1942, the program was in full motion. Ships rolled down the ways with such frequency that naming ceremonies became routine. Champagne bottles were smashed, speeches made, and within hours, another hull was being assembled on the same slipway. The pace astonished foreign observers. British naval officers visiting Richmond compared it to a miracle factory. Soviet envoys watched in disbelief as ships were completed faster than their crews could be trained. The Liberty ship had become a symbol of American industrial might, proof that democracy could outproduce dictatorship. Yet the program was not without problems. Early ships suffered from brittle steel that caused cracking in cold weather. Investigations revealed that the speed of production had outpaced the metallurgical science of the time. Adjustments were made, new alloys introduced, welding techniques refined, and structural reinforcements added. The program adapted quickly, and by late 1943, failures had virtually disappeared. Each setback only sharpened the system's precision. The sheer scale of the Liberty ship program created new logistical challenges. Launching 3 ships per day meant enormous demand for engines, propellers, and crew training. The Maritime Commission coordinated with the Navy and Merchant Marine to ensure every vessel was manned and deployed efficiently. Entire fleets of newly built Liberty ships carried supplies to North Africa, the Pacific Islands, and later to Normandy. Each one played a role in the steady push toward victory. At the peak of production, the average construction time for a Liberty ship was 42 days, the record set at Kaiser's Richmond Yard number. 2 was the SS Robert E. Peary, completed in just 4 days, 15 hours, and 29 minutes. Newspapers around the world printed the story with disbelief. How could a ship the length of a football field be built faster than it could be painted? The answer lay in the modular system. Every piece had been pre-assembled, welded, and inspected before the keel was even laid. When the first section touched the blocks, the rest followed with mechanical precision. The Liberty ship's design, though plain, was brilliant in its simplicity. At 441 feet long and 57 feet wide, it could carry a full complement of cargo across the Atlantic on minimal fuel. Its triple expansion steam engine, though slow, was reliable and easy to repair. Crews nicknamed the ships "ugly ducklings," but they proved resilient under fire. Many survived torpedo hits or collisions that would have sunk more expensive vessels. Their low cost and sheer numbers made them replaceable, a strategic advantage that overwhelmed the Axis. One Liberty ship, the SS Jeremiah O'Brien, made 7 voyages to Normandy during the D-Day invasion. Another, the SS John W. Brown, transported troops to the Mediterranean and later served as a school ship. Both survive today as museum pieces, silent witnesses to an era when steel and labor reshaped the world. The Liberty ship program also reshaped America's geography. Entire cities grew around the new shipyards. Richmond, once a quiet town on the San Francisco Bay, became one of the largest industrial centers on the West Coast. Portland's population doubled within 2 years. In the South, Mobile and New Orleans turned from sleepy ports into bustling hubs of wartime production. The economic impact lasted long after the war ended, laying the foundation for post-war prosperity. The program's influence extended far beyond shipbuilding. The principles developed in the Liberty yards, modular construction, standardized parts, continuous flow assembly, would later be applied to everything from housing to aerospace. NASA's spacecraft assembly methods, decades later, owed much to techniques first perfected under Henry Kaiser's cranes. The Liberty ship was more than a vessel. It was a prototype for modern mass production. Despite their success, the ships themselves were never meant to be beautiful or enduring. They were designed for 5 years of service at most. Many were scrapped soon after the war, their steel recycled into peacetime projects. Yet some endured for decades, serving in merchant fleets, relief missions, and training programs. A few, remarkably, remained in use into the 1970s, a testament to the strength of their design. By the war's end in 1945, Liberty ships had carried 2/3 of all Allied cargo across the oceans. They transported troops to every major front, ferried supplies for invasions, and returned home filled with wounded soldiers and refugees. Their grey hulls formed the arteries of the Allied war effort, pumping lifeblood into every campaign. Without them, the war could not have been sustained. The program's scale remains almost unimaginable. Between 1941 and 1945, American shipyards built more than 5,700 merchant and naval auxiliary ships. Of these, the 2,710 Liberty ships formed the core. The combined tonnage exceeded that of all Axis merchant fleets combined. Germany could sink them faster than any other vessel, but America could build them faster still. It was a contest of endurance, and the Liberty ship program ensured that the Allies would never run dry. The story of the Liberty ships is also a story of faith. Faith in human ingenuity, in ordinary workers, and in the belief that speed and quality could coexist. When the first ship slid into the water in 1941, skeptics predicted disaster. By 1945, those skeptics had been silenced by thousands of ships crossing the oceans, each one a triumph of organization and courage. When the war ended, many shipyard workers returned to civilian life, but the legacy of their labor endured. The same workers who once welded Liberty hulls went on to build bridges, highways, and factories during America's post-war boom. They carried with them the lessons of coordination and precision learned under the pressure of war. In later decades, historians would look back on the Liberty ship program as the defining example of wartime mass production. It embodied the spirit of American adaptability, the ability to transform an entire economy into a machine of creation rather than destruction. Henry Kaiser's yards had proven that speed need not mean sacrifice, that innovation could triumph over tradition, and that democracy could build with the same intensity that dictatorships destroyed. By the time the final Liberty ship was launched in 1945, the tide of war had already turned irrevocably. The convoys crossing the Atlantic no longer feared starvation or shortage. Every port overflowed with ships bearing the same unassuming design, each one carrying a piece of the American promise that freedom, once armed with ingenuity, could outbuild tyranny. November 8, 1942. Richmond, California. The air above the bay smelled of iron and salt, thick with fog that glowed faintly in the glare of arc welders. Long before dawn, the shipyard was alive. Cranes groaned overhead, hauling prefabricated hull sections through the mist. Rail cars clattered over steel tracks, delivering deckhouses and bulkheads, still warm from the welding shops. Thousands of workers streamed through the gates, lunch pails in hand, their breath rising in white clouds. The whistles blew, and the night shift passed its place to the day. In yard number 2, preparations were already underway. for something no one in naval history had ever attempted: the construction of a full-sized Liberty ship in less than 5 days. The vessel would be named SS Robert E. Peary, and by the time it touched the water, it would stand as the ultimate proof of what Henry Kaiser's modular system could achieve. The plan was audacious even by Kaiser's standards. A normal Liberty ship, built using prefabricated methods, still required roughly 40 days from keel to launch. The best record to date was 10 days, an astonishing figure in its own right. But Kaiser wanted to break the psychological barrier of a week. He wanted to show Washington, the press, and the world that the American shipbuilding system had reached a level of coordination beyond imagination. If a single ship could be completed in under 5 days, it would silence every critic who had once called his methods reckless or impossible. The idea originated in October 1942 during a meeting at the Maritime Commission's West Coast office. Kaiser's production superintendent, Charles H. Reed, proposed a demonstration build, not for combat, but for morale. "We can do it in 5 days," he said flatly, spreading the blueprints across the table. "Everything prefabricated, everything ready, all crews standing by. Just give us the green light." The commission hesitated. The goal seemed absurd. But Kaiser nodded, tapping the edge of the drawing with his pen. "5 days," he said. "Let's show them what America can do." Preparation began immediately. Every component of the ship was scheduled to the minute. Hundreds of subassemblies were fabricated in advance. Bow sections, stern frames, cargo holds, and deck houses. Welders worked day and night, stockpiling finished modules in the yard's open spaces, each tagged and catalogued for rapid installation. Supply lines were tightened until not a single bolt or plate was missing. Thousands of man-hours were invested before the first keel block was even laid. The workers understood what was at stake. This was not merely a construction project, it was a performance for history. On the morning of November 8th, the experiment began. At exactly 12:01 a.m., the first keel plate of the SS Robert E. Peary was lowered onto the slipway. Floodlights turned the yard into a scene of daylight, reflecting off pools of rainwater and bare steel. Teams of welders swarmed the plate, sealing the joints with blue fire as inspectors followed close behind. Each completed seam was marked in chalk, one of thousands that would be checked before launch. The work advanced not by chance, but by choreography. The modular system made it possible. While the keel was being joined, cranes already positioned massive prefabricated sections nearby. Each piece weighed tens of tons and contained pre-installed pipes, ladders, and electrical conduits. Within hours, they were lifted into place and fused to the growing hull. Every motion had been rehearsed. Crew leaders shouted orders, sparks showered into the fog, and the great ship began to take shape with mechanical precision. By dawn of November 9th, barely 5 hours into construction, the ship's bottom shell was complete. By noon, the first bulkheads rose into position. Newspaper photographers captured the surreal sight of a ship growing in real time, like a steel organism feeding on fire. One journalist wrote, "You can stand at the pier and see history forming by the hour." The pace was relentless. The yard's loudspeakers played swing music to keep morale high. Mess wagons rolled between crews, serving coffee and sandwiches without stopping work. When night returned, portable floodlights lit every corner of the yard. The glow could be seen for miles across the bay. Richmond's residents gathered along the waterfront just to watch. Some thought the shipbuilders were attempting the impossible. Others simply wanted to witness the sight of speed turned into spectacle. Kaiser's leadership style fueled the momentum. He moved through the yard constantly, clipboard in hand, shaking hands with welders and foremen alike. "You're building faster than history," he told one crew chief as they sealed the midship joint. To another he said, "Every spark tonight is a message to Berlin and Tokyo." His confidence was infectious. Workers who had once doubted their endurance found themselves working 12-hour shifts without complaint. The excitement of the record attempt turned exhaustion into pride. By the second night, November 9th turning to November 10th, the hull of the Peary was nearly complete. Crews had logged 24 hours straight, rotating in precise shifts. Over 1,200 welders worked simultaneously on different sections. The air shimmered with heat and ozone. Inspectors moved quickly, examining seams with portable X-ray machines to ensure no flaws escaped notice. Every completed section was immediately covered by painters, spraying protective primer. The numbers defied belief. The Peary's hull weighed 3,400 tons and stretched 441 feet from bow to stern. Its deck plates, pre-cut and numbered, fit together with the precision of puzzle pieces. Each installation was followed by a chorus of welders, sealing the joints in a cascade of sparks. The rhythm never broke. When a crane jammed at 3 a.m., replacement equipment was delivered within minutes. Nothing slowed the pace. By sunrise on November 10th, the hull was complete to the main deck. Electricians followed behind the welders, threading cable through conduits already built into the sections. Plumbers connected pipes for ballast and bilge systems. The engine assembly, a 2,500 horsepower triple expansion steam engine, had been pre-tested and delivered whole. It was lowered into place by the yard's largest crane just after noon. The operation, which once took 3 days in a conventional yard, was completed in under 3 hours. The engine fit perfectly. The press had begun to arrive by this point. Reporters from Life, Time, and the New York Times crowded the observation platform, cameras flashing as cranes swung sections into place. The story was spreading across the country. "5 days to build a ship," blared the headlines. Radio commentators described it as a miracle of production. To the men and women inside the yard, it was less miracle than mathematics. Every cut, every weld, every delivery had been timed with a precision few factories had ever achieved. By the morning of November 11th, the third day, the ship's superstructure was complete. Deck houses, bridges, and funnel sections were hoisted into place like building blocks. The funnel was welded by a team of women welders from Oakland, celebrated in photographs that would appear on posters across America. One of them, a young woman named Elizabeth Cortez, later recalled, "We didn't feel like we were making history. We were just trying not to fall behind schedule." The Peary's construction became a national event. Schools in California dismissed classes early, so students could visit the waterfront. Telegrams poured into Kaiser's office from government officials, including a brief message from President Roosevelt, "The eyes of the nation are on Richmond." The workers taped it to a wall near the main gate. Beneath it, someone scrawled in chalk, "We'll make him proud." The fourth day brought final assembly. Shipfitters bolted down deck machinery, while painters applied the last coat of grey hull paint. Lifeboats were hoisted aboard. Electricians wired navigation lights and radios. Crews worked through another night to prepare for launch. On November 12th, at 3:27 p.m., just 4 days, 15 hours, and 29 minutes after the first keel plate was laid, the SS Robert E. Peary slid down the greased ways into the water. A crowd of more than 30,000 people filled the docks. Bands played Anchors Away. Confetti rained down from scaffolds. The ship's sponsor, Mrs. Robert Peary, widow of the Arctic explorer for whom the ship was named, smashed a bottle of champagne across the bow. "May she serve the cause of freedom," she declared. As the hull struck the bay, water surged over the rails, soaking spectators near the pier. The roar of the crowd drowned the sirens. Reporters filed their stories that evening, describing the event as an industrial wonder. The San Francisco Chronicle called it a new chapter in shipbuilding. The New York Times reported, "A miracle of steel and speed has been achieved at Richmond." The Maritime Commission released an official statement confirming the time record: 4 days, 15 hours, 29 minutes, from first weld to launch. No ship of comparable size had ever been built so quickly in human history. The numbers behind the feat were as extraordinary as the record itself. Over 1,400,000 man-hours had been compressed into a fraction of normal time. 22,000 workers contributed in shifts around the clock. More than 250 cranes, trucks, and welding machines were used. The process consumed 3,200 tons of steel, 50,000 feet of pipe, and over 600 miles of welding bead. Each detail had been planned, each second accounted for. When the Peary touched the water, it represented the absolute peak of wartime industrial coordination. The psychological effect on the nation was immediate. Newspapers printed photographs of the ship under the headline, "Built in 5 days, America can't be stopped." Newsreels played in theaters across the country, showing sped-up footage of the ship's construction. Audiences watched in awe as cranes swung in rhythm and welders moved like sparks themselves. The film ended with a simple caption, "Speed is the weapon of victory." In Washington, the Maritime Commission used the success as propaganda proof that mass production could overcome any obstacle. It wasn't just about ships, it was about the mindset behind them. If America could build a vessel in 5 days, it could build anything. For the workers of Richmond, the record was a badge of honor. A commemorative plaque was placed near the slipway, reading, "Here was built the SS Robert E. Peary, launched in 4 days, 15 hours and 29 minutes, a symbol of American ingenuity and unity." The workers signed their names on the back of the plate before it was bolted in place. Many of them would continue working at the yard until the end of the war, launching hundreds of ships. But none would forget the week they built one faster than anyone thought possible. The Peary's story did not end at launch. After outfitting, the ship was sent into active service, carrying supplies to the Pacific. It completed multiple voyages between 1943 and 1945, transporting everything from munitions to food for Allied troops. The vessel performed without incident, proving that speed had not come at the cost of strength. Its welded seams held firm through storms and long voyages. It was a testament to the quality of Kaiser's workforce and the reliability of his methods. Naval engineers studied the Peary as a case study in extreme efficiency. They discovered that the modular process had not only reduced construction time, but had improved quality control. Because each section was built independently, inspectors could examine every weld before assembly. Defects were corrected early, eliminating the need for costly repairs later. The record build, far from being a publicity stunt, demonstrated a new industrial model, one that prioritized parallel progress over linear sequence. Foreign observers took notice. British engineers visited the Richmond yards in early 1943 to study the process. They returned to Clydebank with new ideas for their own shipyards, applying modular construction to post-war projects. Soviet officials, impressed by the Peary's success, requested technical data for similar programs at Murmansk and Leningrad. The influence of one ship built in 5 days rippled across continents. Within the United States, the feat spurred even greater production goals. Kaiser's shipyards continued to push limits, reducing average build times for Liberty ships to under 30 days and for smaller tankers to less than 20. The Peary remained unmatched, but it served as a benchmark, the impossible standard that every crew silently aimed to equal. Workers referred to it simply as the 5-day ship. For Henry Kaiser, the achievement confirmed his philosophy. He told reporters, "It proves what can be done when men and women are united in purpose. We don't build ships, we build confidence." His words resonated across the nation. The Peary became a symbol of American ingenuity, not just a vessel, but an idea forged in steel. After the war, the SS Robert E. Peary continued in civilian service, carrying cargo through the late 1940s before being decommissioned and scrapped. Its lifespan was short, but its legend endured. Photographs of its construction still appear in textbooks, illustrating the zenith of wartime efficiency. The slipway where it was built is gone, replaced by quiet warehouses, but the story remains etched in the memory of industrial history. Historians later described the Peary as the perfect intersection of innovation, coordination, and urgency. It was the visible outcome of every lesson learned from the Modular Shipyard system, the Welding revolution, and the Liberty ship program. In a single demonstration, it encapsulated the essence of American wartime production: speed without sacrifice, quantity without chaos. The record has never been broken. No nation, in peace or war, has built a full-sized ocean-going cargo ship in less time. The Peary's achievement belongs to an era when necessity compressed invention into days and nights of unstoppable motion. It remains one of the purest symbols of industrial will ever recorded, proof that with planning, precision, and courage, even steel could be made to move faster than time. And so, in the chill of that November afternoon, as the SS Robert E. Peary floated free for the first time, America caught a glimpse of what its factories, its workers, and its imagination could achieve when pushed beyond the possible. The record wasn't just measured in hours, it was measured in resolve. 4 days, 15 hours, 29 minutes, and the unshakable conviction that speed itself could be a weapon. January 12, 1943. Pittsburgh, Pennsylvania. The temperature hovered just above freezing as steel workers at the Jones and Laughlin mill poured molten metal into molds, sparks shooting 10 feet into the air. To the men sweating inside the foundry, it was just another shift. They had no reason to know that the steel they shaped that night would soon travel 2,000 miles west to become the keel of a ship built in less than a week. From the smelters of Pennsylvania to the welding arcs of California, the pulse of a single industrial organism beat across the entire nation. A coordinated network of factories, foundries, and freight lines so vast that no one man could see it whole. This was the Liberty Fleet, not a navy of ships, but a system of production, the most extraordinary demonstration of industrial scaling in human history. By early 1943, the Liberty ship program had evolved beyond a collection of shipyards. It had become an interconnected web of more than 10,000 companies working together under one purpose: to feed the shipyards with an uninterrupted stream of standardized parts. A single Liberty ship required components from at least 32 states. Steel plates came from the Midwest, engines from Ohio and New Jersey, boilers from Massachusetts, pumps from Michigan, paint from Illinois, rope from Kentucky. Each item followed a schedule of production as exact as a military timetable. The system depended not on improvisation, but on precision, an invisible clockwork that ticked beneath the surface of America's wartime economy. In Washington, the U.S. Maritime Commission and the War Production Board coordinated the flow. Their offices became command centers of logistics, tracking thousands of shipments daily. On their walls hung enormous maps threaded with colored strings, each representing a train route or supply chain. Lines ran from steel mills to assembly plants, from foundries to shipyards, from the Great Lakes to the Pacific coast. At any given moment, more than 10,000 freight cars carried Liberty ship components across the country. Each piece had a destination, a deadline, and a code number. The margin for delay was measured in hours. Henry Kaiser's shipyards in Richmond served as the ultimate test of this coordination. Every vessel launched there depended on the timely arrival of parts from hundreds of subcontractors. To manage the flow, Kaiser created what he called the Flying Squadron, a team of logistics experts who traveled constantly between suppliers, solving bottlenecks before they became crises. If a shipment of steel was delayed in Denver, the squadron rerouted trains from Chicago. If a shortage of valves threatened to halt engine assembly, new suppliers were recruited within days. The speed of problem-solving became as vital as the speed of welding. What made this system revolutionary was standardization. Each Liberty ship, though assembled in different yards by different hands, was built to identical specifications. Every beam, plate, and pipe was numbered according to the same blueprint. A hull section fabricated in Portland could be fitted perfectly to one in Baltimore. A replacement rudder forged in Alabama could attach seamlessly to a vessel built in Oregon. It was the first time in history that an entire fleet had been constructed not as individual ships, but as interchangeable units of one design. The concept of interchangeable parts was not new. It had powered America's manufacturing rise since the days of Eli Whitney. But never before had it been applied on this scale. The Maritime Commission insisted on exacting tolerances. Steel thicknesses were standardized to the nearest thousandth of an inch. Bolt holes were aligned to universal coordinates. Subcontractors were audited regularly to ensure compliance. The result was a kind of industrial language shared by thousands of companies, a dialect of dimensions, materials, and specifications that allowed components from across the continent to fit together without adjustment. The logistical challenge of moving these components was immense. Trains became the arteries of the Liberty fleet. Every day, freight cars left Pittsburgh, Cleveland, and Detroit loaded with finished sections. Locomotives thundered west through snow-covered passes, their boxcars stenciled with the words, "Maritime Commission Priority." Rail dispatchers gave these trains right-of-way over all others. At junctions, entire rail yards were cleared to let them pass. To the railroad men, they were known simply as Liberty Specials. When the trains arrived in California, cranes unloaded the cargo directly onto trucks bound for the shipyards. Each shipment was checked against a manifest before being placed in the prefabrication shops. The flow was constant. Steel in, ships out. At the height of production, the Richmond yards consumed 1,200 tons of steel per day, 400,000 feet of pipe, and enough welding rod to stretch from San Francisco to Chicago. Yet not a single ship ever missed its launch date for lack of material. The efficiency owed much to the rise of new technologies in scheduling and communication. Kaiser's engineers pioneered one of the earliest forms of real-time data tracking. Each subcontractor reported progress daily via telegraph to a central coordination office. Delays were plotted on large wall charts marked with colored pins: red for late, green for on time, yellow for under review. Every morning, the logistics team gathered to update the map. The goal was a field of green. By 1943, it almost always was. To outsiders, the system appeared impossibly complex. To those within it, it felt simple, a matter of rhythm. In Chicago, workers at the Continental Foundry cast propeller blades 24 hours a day. In Akron, Goodyear produced miles of hose for fuel lines. In Detroit, the Chrysler Corporation converted assembly lines once used for automobile engines to manufacture Liberty ship turbines. Each plant operated independently, yet harmonized as part of a national machine. The blueprint for one ship was identical to that of the next, allowing thousands of parts to move like notes in a symphony of steel. The heart of this system was trust. Subcontractors had to believe that their components would arrive on time, be assembled correctly, and serve a larger purpose they would never personally witness. A worker riveting an engine plate in Newark might never see the ocean, but his labor would help launch a ship halfway across the continent. This psychological unity, the sense of belonging to something vast and purposeful, became one of the Liberty Fleet's greatest strengths. The scale also demanded innovation in packaging and shipment. Prefabricated sections, too large for boxcars, were carried on flatbed rail cars with special supports. Smaller parts were packed in standardized crates, marked with stenciled numbers, indicating their destination yard and section. A crate labeled 2A47 might contain the piping for hold number 2, section A, frame 47 of a particular ship. When it arrived, workers knew instantly where it belonged. The elimination of confusion saved thousands of hours per month. At every stage, efficiency bred more efficiency. When steel mills adopted faster production methods, shipyards received their materials sooner, allowing them to increase output. The shipyards, in turn, placed larger orders, justifying further expansion of the mills. The cycle became self-reinforcing, a feedback loop of productivity that accelerated with every success. Economists later described it as the logistics spiral, the first true example of a self-sustaining industrial ecosystem. By mid-1943, the system had matured into something approaching perfection. The Maritime Commission no longer tracked ships individually, but in batches. Orders were placed for 10 or 20 hulls at once, their components flowing through the same national supply chain. At any given moment, as many as 300 ships were under construction simultaneously at 20 different yards. Each one drew from the same river of resources, a current of steel, wire, and machinery flowing ceaselessly across the country. The magnitude of coordination astonished foreign observers. British production officers visiting in 1943 described the American system as a wonder of logistics and faith. Soviet engineers who toured Kaiser's Richmond yards compared it to a military operation. One remarked, "We fight with divisions of men. You fight with divisions of factories." The comment was not far from the truth. The United States had transformed its industrial base into an army of production. Every plant, every worker, every train was part of the Liberty Fleet's campaign. Even failures contributed to improvement. When a shipment of defective boilers from a supplier in New England caused delays in late 1942, Kaiser's logistics team responded by establishing a rotating quality control unit that traveled directly to factories. Instead of inspecting parts after delivery, they inspected them at the source. The result eliminated nearly all future defects. The same method was soon adopted nationwide, creating the first decentralized system of industrial quality assurance. Perhaps the most remarkable aspect of the Liberty Fleet's scaling was its flexibility. When the Navy required a sudden increase in tanker production in 1943, the same network seamlessly adapted. Prefabrication shops switched from cargo holds to cylindrical tank sections overnight. Train shipments were rerouted accordingly. Not a single delay rippled through the system. It was as if the entire network could change direction with a single command, an industrial organism capable of self-correction. Behind the statistics lay the human stories of those who kept the system moving. Telegraph operators working night shifts in Kansas City relayed shipment data from coast to coast. Railroad conductors slept in their engines between runs to meet the unending demand. Factory foremen, once accustomed to peacetime production schedules, found themselves managing 24-hour operations. Many worked until exhaustion, but few complained. They understood that every day gained meant lives saved at sea. The Liberty Fleet's efficiency also depended on new methods of storage and inventory. The shipyards adopted flow-through systems, where materials spent no more than 48 hours in storage before being used. Warehouses operated on just-in-time principles, decades before the term existed. Supplies were unloaded, sorted, and delivered directly to assembly stations without pause. The reduction in idle stock freed enormous amounts of space and cut waste to nearly zero. By 1944, the scale of production had reached numbers that defied comprehension. America's shipyards launched 1,154 Liberty ships that year alone, an average of more than 3 per day. Each launch triggered a chain reaction through the supply network. New orders, new shipments, new schedules. Steel mills expanded capacity to keep up. Railroads lengthened sidings to handle the traffic. The industrial organism grew stronger with every success. The Liberty Fleet also transformed the cultural landscape of the nation. Newspapers began referring to factories as home front battalions. Posters urged citizens to keep the fleet flowing, showing lines of Liberty ships stretching to the horizon. School children collected scrap metal for recycling. Housewives volunteered at rationing offices. Every American, directly or indirectly, became part of the supply chain. The sense of participation unified the country in a way no speech could. At the administrative level, the logistics were staggering in complexity. Each shipyard maintained thousands of procurement contracts. Every contract required coordination between private companies, government agencies, and labor unions. Yet despite potential chaos, the system rarely faltered. The key was communication. Kaiser's offices issued weekly bulletins listing production achievements, supply updates, and commendations for exceptional performance. Factories that met quotas received public recognition, fostering competition between suppliers. Pride became an engine of efficiency. Railway workers called it the Invisible Navy. They spoke of trains carrying rudders through the Rockies and propeller blades across the desert. At night, long lines of flat cars shimmered beneath the moonlight, steel for ships that did not yet exist. To the engineers who drove those trains, the sound of their locomotives echoed with the same urgency as a convoy's engines at sea. Every whistle that blew in the night was part of the same song, the anthem of the Liberty Fleet. The scale extended beyond material to human logistics. The Maritime Commission worked with state employment agencies to move laborers wherever they were needed. Trains carried entire families to new shipyard towns built overnight on the Pacific coast. Housing projects like Richmond's Atchison Village and Portland's Vanport sprang up to accommodate them. Each new worker meant another pair of hands in the assembly line, another link in the chain of production. By 1945, the system had reached its peak. The United States had built more ships faster than any other nation in history. The Liberty fleet numbered over 2,700 vessels, and behind each one stood an invisible fleet of factories, hundreds of thousands of machines humming in synchrony. The program had proven that industrial warfare could be fought like any other campaign, with planning, supply lines, and relentless coordination. When victory came, the Liberty Fleet's logistical miracle became the foundation for post-war America. The same networks that once moved steel and engines began moving automobiles, appliances, and construction materials. The highways and rail systems built to serve the war effort became arteries of peacetime prosperity. The principles of standardization, interchangeability, and mass logistics became the blueprint for the modern global economy. Historians would later call it the triumph of organization, the moment when America's genius for coordination surpassed even its capacity for invention. The Liberty Fleet was more than a collection of ships. It was proof that a free society, when united by purpose, could mobilize faster and more efficiently than any totalitarian regime. It turned diversity into strength, distance into advantage, and chaos into order. In the end, every Liberty ship launched from every yard carried more than cargo. It carried the weight of an entire nation's machinery, synchronized across time zones and industries. Each vessel was a floating symbol of connection, between miner and mill worker, between welder and rail engineer, between the unseen millions whose collective effort transformed raw material into victory. The Liberty Fleet's industrial scaling was not merely an achievement of engineering. It was a testament to will, to the belief that coordination itself could be a weapon. From the furnaces of Pittsburgh to the slipways of Richmond, the hum of industry became the sound of freedom being built, one standardized part at a time.